All right. Good afternoon. No, good morning. It's still the morning. This is Tuesday, June 2nd. This is AP Computer Science A. Caden jumping in right at the end here, but he's on time. We're just about ready to get started. Actually, couldn't have been more on time. So that's awesome. Thank you so much for stopping by this morning. Our last week of AP Computer Science A, and in fact, the last class that I am going to record and post online. So today, what I would really like to do is I'd like to go over sort of a year in review of AP Computer Science A and say, as a student that has now completed AP Computer Science A, Molly jumping in too, which is great. Couldn't have been more on time. We're just about to get started. As a student completing AP Computer Science A, this is what you should be able to do. This is what you should be confident in knowing, and this is the skills that you should have going forward. All right. Having AP Computer Science A on your transcript really means that you've accomplished what I'm about to list on paper for you. And if you feel that that's not the case, if I list something here and you're like, shoot, I have AP Computer Science A under my belt, but I still don't understand arrays, for example. I don't know how you could not at this point, but hey, it could be a thing. Um, Maybe that's a good indication that if you are going to take any future computer science classes, particularly at a college level, these are the concepts that you would already be expected to know. You would already expect to have exposure to this. If a professor or a university admissions person looks at your transcripts and sees AP Computer Science A, then they'd be like, wow, well, you've already talked about and you should already have mastery of X, Y, and Z. So that's what I'd really like to outline for you today. Should be a nice wrap up of everything we've talked about in AP Computer Science. As far as your text games go, I have had the chance to play some of them, not all of them. Specifically, I had to play those that were doing the URI dual enrollment first, so I could submit your grades immediately. So those are already done. I am going to play the rest of them, I believe, on Wednesday. We'll find some time tomorrow to try to play the rest of them. But the ones I've played so far, I have to say I'm very impressed. I have to say that given the distance learning environment, it's not that I had low expectations for you. I don't want that to be the message that I send across here. It's that my expectations were certainly tempered because of the differing circumstances. The fact that you probably did not have quite as much time to work on it as if we were in class. The fact that you weren't able to probably regularly meet up and work on it together. You probably had to work via a Google Meet or any other sort of medium that you use to communicate with each other. So it's not that I had low expectations, but I was like, oh, it would be fine if the games are a little lacking in certain areas. And I have to say that I was very blown away. These games are definitely standing up. For the most part, they're standing up to the standards for previous years when people have had more time to work on their games and when people have had, me more readily available to answer any questions. And I just have to say overall that I'm very impressed. So I really appreciate you guys rising to the occasion to get these games done. The way that I am grading the games is they are accounting for 2 progress assessment grades for the end of the quarter that will round out the AP Computer Science grades for the year. The 2 ways that I'm scoring them is they are graded on, number 1, do they actually reflect that you demonstrate or that you understand the concepts that we've learned in AP Computer Science A this year? So if you make a very engaging game and it's super fun and I look at your code and it's just a big cluster of if statements, well, that's great that you were able to make a great game, but it doesn't really demonstrate to me that you know what we talked about in AP Computer Science. We talked about objects, we talked about arrays, we talked about loops, we talked about all that stuff. So all that stuff should be incorporated in some way into your game. The second grade, though, is on its actual gameplay. Is it easy to understand? Is it accessible? Is it actually fun and engaging? Was I confused as to what to do? Was it unclear? All those types of questions are really what that second grade is all about, because ultimately, when you're designing a software application, be it a game or another tool that another company will use or something like that, it needs to be accessible and engaging. That's really like the simplified version of what it needs to be, because users are going to use it. And it's very simple, speaking from personal experience, to try to develop a game, think that something is super clear, and then somebody goes ahead and boots it up and says, what do I do? And you're thinking to yourself, what do you mean, what do you do? How do you not know what to do? but it's because they've never seen it before and they've never played it before. And the same thing is true of any software application that you write. It's going to be very obvious to you that, oh yeah, you boot it up, you log in, you do all this stuff. But somebody else, I mean, you've probably seen it. If you give someone a smartphone that is technologically illiterate or has difficulties with technology, they're like, I don't know what to do with this thing. So they're like, hold it like this when they talk to people. You know, it's the same deal with your software application. You're going to notice the same things. So that's why your second grade is based on what it's based on. All right. So those two grades together will, like I said, complete your AP Computer Science grades for the fourth quarter. So there are no more grades being issued this week. All right. And those should be all up to date tomorrow. All right. Any questions on anything I've said so far?
Nope.
Thanks, Andrew. So let's go ahead and actually just review some AP Computer Science. So going out of AP Computer Science, now transitioning from AP Computer Science A to the great beyond, whatever lies in wait beyond AP Computer Science A for you, you should really know the following. So you should have under your belt, and I am going to, by the way, I'm going to be specific with Java for my terminology, but that doesn't mean that your knowledge should be limited to Java. The fact that we talked in Java all year and our class is based in Java and the AP Computer Science A exam is in Java, that's great. And Java is a very important language, I believe, to become proficient with. I think it's probably the best, maybe next to Python, it's the best language for introductory students to learn. And the reason for that is because it's still the industry standard throughout the business world. Yes, a lot of businesses use their own sort of versions of Java or their own languages that they've developed in-house, but they're all somewhat derivative of Java for the most part. Even JavaScript, which is quickly gaining popularity, is obviously derivative of Java. So I think that's why it's really important. So even though I'm going to say, yes, we've learned this all in Java, that doesn't mean that you can't pick up now something in Python and understand it and roll with it. Okay, so your skills should be very transferable amongst other programming languages, even stuff like C and C++, which are definitely a lot more limited in what's possible to do with those types, or not limited, I don't want to use that word, definitely more involved as to what's possible to do. Like, in order to do something in C++, it might take like 10 lines, and something that can be done in Java. Granted, it could be more efficient and more memory managed, but still. Little too complicated for our taste here, doing an introductory level. So your skills should be transferable. And ultimately, the last note I want to make before I start writing stuff is that you should hopefully have learned how to problem solve in computer science. That was a big part of me giving sort of open-ended programming tasks throughout the year, was for you to figure out how to problem solve, how to be faced with something and be like, how do I actually make this application work, and break it down to a step-by-step thing. I think that is the most important takeaway of computer science. To be able to look at a problem and figure out, I want to accomplish X, how do I make that happen? What is the step-by-step process I need in order to achieve that? So let's actually go through now the specific skills though. So the really first thing that we started with was Java fundamentals. Okay? And by Java fundamentals, I really mean that you should be able to work with primitive data and understand like ints, doubles, booleans, all that stuff. You should be able to understand what math operators and comparators. So math operators being plus, minus, times, divide, noting how integer division works. Mod, we talked about. Comparators, greater than, less than, equal to, not equal to. All those stuff you should be able to do. That also includes math.pow, math.random, all that stuff should be incorporated in Java fundamentals. You should know how to work with primitive data, math operators. You should know how to do like printing, output, and reading input. Okay. So if you remember, that was sort of the focus at the very start of the year. All the Java fundamentals of how do you code in Java, maybe comments you could even throw in there, and basics of how you can store and manipulate data, and retrieve data from the user. Second thing was conditional statements. and loops. That's another big topic. So you should be comfortable with basic if-else statement structures, meaning that if a certain condition is true, then do this, and if that condition is not true, then do this. You should be also comfortable with multiple conditions chained together. I'm going to say exactly that, chained together. You should be comfortable with like 3 cases potentially, or 4 cases, or 5 cases, or having if statements with ands, ors, and nots thrown in there, if this is true or this is true. So all that stuff should be pretty pretty understood by this point. You should also understand the difference of for and while loops. You should know when to use for and while loops. You should know, like, while loops is used when you don't know the number of repetitions, and for loop is used when you do, typically. You should understand the structure of nested loops. What happens when you put a loop inside of a loop. One of the most basic parts of that is what you've probably done for a lot of programs now, which is sort of a run again feature. Would you like to run this program again? And in order to do that, you pretty much put your whole program in a while loop. So that's having loops inside of loops. Okay. So nested loops, very, very important as well. And just generally using loops to accomplish a lot of stuff. Speaking of which, we then talked about arrays. And so you should be very comfortable with the structure of an array. So structure, and this is just one-dimensional. So structure of an array, like what it is, the fact that it's a list of data started numbering at index 0 to index n-1. You should be very comfortable with traversing an array. So being able to access different indices in an array, being able to use a loop to go from the beginning of the array to the end of the array, or backwards if you so desire. You should be comfortable with modifying and accessing array data. And you should also be very comfortable with like extracting information from arrays. And by that I mean like looking at an array of integers and being able to write a program to find the largest one. Or given an array of doubles, you should be able to find the average of all of the double values in the array. Or maybe given an array of strings, find out how many of those strings have more than 7 characters, right? You should be able to do all of those types of things with arrays. You should be able to manipulate them, work with them as much as you can. Same thing with arrays in 2D. So remember, 2-dimensional arrays are like grids. So you should be comfortable with, again, the structure of a 2D array. You should be comfortable with how to access and modify and traverse, essentially all the same stuff for arrays. How to access and modify and traverse. Okay, really all the same concepts for a 1D array now applied to a 2-dimensional array. Okay, 2-dimensional array computations for AP Computer Science don't go nearly as in depth as the 1D ones did, but they're still important, and you should still be comfortable with the fact that a 2D array is essentially an array of arrays. It's a list of lists, and it can be visualized as a grid. Okay, we talked about strings and methods. Those were 2 big things. So if you have a string, you should understand what a string is. So the string objects, the structure of a string. You should understand and be able to use some of the methods included in the string object. So like index of, substring, to uppercase, to lowercase, compare to, all those types of things. You should be able to use all of those with the string object. Equals, that's another good one. You should just be familiar with methods in general. So the purpose of methods. Hopefully you noticed as you were writing your games, your text games, why methods are particularly important, because you probably found yourselves rewriting the same lines of code over and over and over, and you might be like, hey, I should probably stick that in a method so I only have to do it once. Definitely why methods are useful and why they continue to be useful. So we have methods, we have just stuff about like return types. The fact that if a method is returning a Boolean, what does that mean, and how should you structure your program to make that happen? If you're given a scenario that you have to create a method for, like if I said create a method that searches through an array and pulls out the largest element, you should understand, okay, what are the parameters that I need to pass in? I should put parameters. What are the parameters that I need to provide the method, and what do I need the method to return? So all that type of stuff is kind of included in that same discussion. You should also understand, within the methods, we also talked about recursion. So in AP Computer Science, we do not go super in-depth on recursion. We just stuck with basic examples of sequences of numbers or letters in some instances, or symbols. In computer science, recursion is a big deal. So if you take higher level computer science classes in the future at a collegiate level or otherwise, recursion is a big thing. It doesn't go away. It definitely comes back, and you talk about it a whole lot. So just make sure that you are aware of that. Even though in AP Computer Science A, it's sort of a, I don't want to say a footnote because it is a big topic that we cover, but it's like just a sort of, oh, by the way, recursion is important, and then this is a small little chapter dedicated to it in AP Computer Science A. In the computer science world, especially in the theoretical side of things, recursion is a big deal. So just be aware of that. That's something that if you take computer science in the future, that's a big thing. Next thing, big topic was objects. So you should be very comfortable with creating your own object at this point, which of course includes all the stuff of constructors. It includes all the stuff of variables, methods, etc. Okay? So you should be very comfortable with creating your own object and doing, applying all of those things appropriately to, create whatever object that you want to create. You should be very comfortable with instantiating an object or initializing an object in a program code. So that's where you'd say like object name equals new object and provide the information. You should be very comfortable with accessing and changing specific data in an object. So if you want to change, if you have, say, for example, the very first object we did is the rectangle object. If you want to change its length, you should be able to do that. If you want to change its width, you should be able to do that. If you want to access that data and just display them, you should be able to do that as well. Okay. You should also be comfortable with arrays of objects, both one-dimensional and two-dimensional. Really just understanding that you can put objects in arrays. You can have an array of objects and how you would access each specific thing in the array of objects. All right. So that's an important thing as well. The actual next topic we talked about after objects, we talked about array lists. Array lists are particularly important in computer science because they are essentially special types of arrays that are generally more convenient and better, but can only be used with objects. So we talked about, the methods of an array list and functionality. The fact that you can use array lists with the fact that an array list has a dynamic size as opposed to a static size, the fact that if you insert an element into an array list, everything else gets shifted down, the fact if you delete something from an array list, everything after that gets shifted up to fill in the gap, just how an array list is structured overall and why it might be useful. I think that's super, super important. You should also have been familiar with using an array list as far as using an array list as part of another object. So using as part of another object. If you remember, in a lot of our free response questions that we specifically took a look at in preparation for the AP exam, the way a lot of methods were, or the way a lot of those objects were structured, was that it gave you this little sample of code for a tiny object, and then another object created an array list of those first objects. We saw that in the one that's coming to my mind right away is the one for cookie sales, where we had a cookie order object, which was just like a little thing about number of boxes and the type. I think those were the two variables. But then, and some sort of master ordering object, it created an array list of those cookie objects, and that it was that master order object's job in order to it was that job to manage and control and modify and play around with that array list. Okay, so you should be comfortable with how array lists can transition from one form to another, right? How they can be used in various contexts. Lastly, we had two other little things. We pretty much finished our discussion, which was good, of inheritance before the distance learning really kicked in, which was good for us. I know that wasn't the case across the board in AP Computer Science classrooms, but we kind of just made it to the end of inheritance before all the madness began. So inheritance, really you should know like why it's useful. Because it allows you to create essentially different objects that share similar attributes. You should also be comfortable with working with arrays using inheritance. So we saw that through inheritance, if we created multiple objects that all inherited from the same thing, even though those objects were of a different type, we saw that you could actually use them in inheritance. You could stick those objects all in the same array if you make that array the general type that like was inherited from, and you could just access all that data that way. That's how, like, think of real world applications. If you have a car dealership, that's how, even though cars are all different, like you have cars, trucks, and all these different types of vehicles, you have all different makes, you have all different models, you have all different colors, that's how they're all stored in essentially one large database. They're probably not all individual objects, they just inherit from the same object and just modify it accordingly. Okay, and that's why they're allowed to be able to store in the same list. Why it's useful arrays. Oh, and also like tracing inheritance hierarchies. Okay, so by that I mean, remember we had problems where it was like, I'm trying to think of a specific example. We had like production P equals new play, and then we kind of went through like a bunch of methods. When you say this sets this as high priority, and this sets this as low priority. So when you're actually looking for which methods will be triggered by certain statements, it will look here first because it's followed by the word new, and then it will look here second. So it's important that you can trace inheritance hierarchies back, and you can understand how using the keyword super will actually go up to the class and grab the information above it so you can use it. Okay. And last but most certainly not least, we talked about searching and sorting. That was a very abbreviated discussion on searching and sorting. Oops, sorting, not sorted. Okay. Sorting. Even though it was an abbreviated discussion, though, you should kind of understand the underlying principles of searching and sorting. It's essentially, the goal of those is to ask, if I have all of this data, number one, how can I access data that I'm looking for? That was your searching methods. How can I actually find something in a list? How do I tell the computer to find something? And sorting was, if I have all this data, how can I get it in a proper order? What is an efficient step-by-step way that I can tell a computer to do that? All right. But ultimately, these are the concepts that you should really walk away from AP Computer Science with a solid understanding of. Loops, arrays, strings, methods, objects, array lists. Having a solid understanding of that from personal experience, I can tell you, it will benefit you immensely in any post-secondary program. It's not, you're not going to walk in and automatically get A pluses, but what I'm saying is you should definitely have a little advantage over other people that may not have had the privilege to enjoy this type of background on computer science concepts. I know for me personally, when I started studying computer science in college, I had no prior programming experience, so going in totally with a blank slate, it was very difficult. It was very difficult to be able to pick up those concepts at a rapid pace. So I'm a little envious of you guys having that background now and going into potentially a college setting. I know I'm talking to mostly juniors here, all juniors, I think. But going into a college setting in 2 years with this background, if you take a computer science class, you'll definitely have a leg up on other people around you, for sure. And it should be to your advantage. All right? Just wait until you get to data structures. Fun times ahead. Fun times ahead. All right. Any other questions, comments, or concerns? That's the year in review for AP Computer Science A. And that's what we got. That's what we did. That's what you guys came, saw, and conquered in AP Computer Science. Any other questions or comments?
Not for me.
Thank you, Andrew. Anybody else? No, it appears not. All quiet. So what I want to say is I do want to thank you for a great year of AP Computer Science A. We do still have one more class next time. I'm not going to record and post that class, though, because of reasons. You'll see, because of reasons. But I do want to say that, thank you for a great year. Hopefully watching these videos back has been helpful as well, as they are recorded and uploaded. I figured that would be helpful in particular for the AP exam. If you ever have any suggestions as to how I can improve AP Computer Science A next year, you can always feel free to reach out and tell me. If you're like Mr. Giorgio, I think you did a great job explaining arrays, for example, but I think, you really kind of skipped over 2D arrays a little too fast, and I really wasn't comfortable with that. That's fine. Let me know. I want to hear all that stuff so that, next year we can make it a little better. But again, thank you for everything, and I hope you have a fantastic rest of your day, and I will see you on Thursday. Bye, everyone.
Have a nice day.
See you, Mr. Giorgio.
Bye-bye, Mr. G.
Mr. Giorgio.
Bye-bye.
Bye, Mr. Giorgio.